Your journey begins not with a bang, but with a breath. Feel it now, a slow, quiet tide pulling into the stillness of your room, and an even slower, warmer tide flowing out. There is no effort here, just a simple, ancient rhythm of your body finding its peace. The thoughts of the day, with their sharp edges and bright colors, are beginning to soften. They recede like footprints in the sand, washed over by the gentle surf of your breathing. In and out, the world outside your walls, with all its hurry and noise, fades into a distant hum, a story that belongs to someone else, somewhere else. Here, there is only the darkness, the weight of the blankets, and you. This darkness is a friend. It is a space of comfort, a return to the simplest state of being. Allow your eyes to close, or to rest softly in the low light. You are safe. You are still. And in this stillness, your mind to begin to wander, not with anxiety, but with a quiet curiosity. Let it drift up past the ceiling of your room, past the roof of your home, and into the cool, vast expanse of the night. You are looking up now into the deep, quiet ink of the night sky. It is a perfect, profound black, a velvet blanket that has comforted thinkers and dreamers for millennia. It is the same sky that your ancestors looked upon, their minds filled with their own stories, their own questions. They saw shapes in the scatter of stars, drawing lines between them to create heroes and monsters, gods and sacred animals. They saw a dome, a celestial ceiling, unchanging and eternal. For them, it was a symbol of constancy in a world of endless change. And tonight, you can feel that same comfort. You can feel the immense, silent presence of sky above, a steady companion to your own small, breathing self. The stars are scattered across this velvet canvas like spilled diamonds. Some burn with a fierce, unwavering light. Others flicker, their ancient light having traveled to unimaginable distances, and the thin veil of Earth's atmosphere to reach you. Each point of light is a sun, a distant furnace warming worlds you will never see. And between them, there is that profound, absolute blackness. It is a quiet that seems to absorb all sound, a darkness that seems to hold all secrets. Your mind can stretch out into it, finding no end, no boundary. It is the purest kind of peace. For thousands of years, we believed this was a portrait of stillness. We saw the slow, predictable waltz of the planets, the stately procession of the constellations across the seasons, but we believed the backdrop itself was fixed. The universe, we thought, was a static, eternal stage on which the celestial dramas played out. It was a comforting thought, the idea of an unchanging cosmos, a reliable foundation for all creation. It felt as solid and real as the ground beneath your feet. But tonight, you will learn to feel its secret motion. Think of a deep, wide river you might see on a calm day. From a distance, its surface looks like a sheet of glass. It appears perfectly still. You see the reflection of the clouds, the trees on the bank, all held in perfect, motionless suspension. But if you were to drop a single leaf onto its surface, you would see it begin to drift, slowly, imperceptibly at first, and then with a gentle but undeniable purpose. The river is not still at all. It is moving with immense, quiet power. Its motion is simply too grand, too uniform, for your eyes to perceive it without a point of reference. Now, think of that velvet blanket of the night sky. The stars are your leaves on the river. For a long time, we watched them and saw only their individual dances around each other, pulled by the familiar forces of gravity. We didn't see the river itself. We didn't realize that the very fabric of space, the deep, dark water of the cosmos, was flowing. Let your mind drift back into that darkness between the stars. It feels like nothing, a perfect void. For the longest time, that's what we thought it was, an empty container, a passive backdrop. But it is not nothing. It is something. It is a substance in its own right, a thing called space-time. And it is alive with a secret energy. Right now, as you lie here, as you breathe in and out, that fabric is stretching. Imagine it like a vast, dark sheet of dough, rising slowly in a warm, quiet room. It doesn't expand from a single point in the center. It expands everywhere at once. Every part of it swells, gently pushing away from every other part. If you had placed tiny sugar crystals on that dough, you'd see them all move away from each other as the dough rises. not because they are rolling around on the surface, but because the surface itself is carrying them along. The galaxies in our universe are those sugar crystals. They are not flying apart through a static, empty space like pieces of shrapnel from an explosion. The space between them is growing. The deep, dark river is flowing. The cosmic dough is rising. This motion is everywhere. It is happening between your home and the nearest star. It is happening between our own Milky Way galaxy and the Andromeda Galaxy. It is happening in the vast, seemingly empty voids between the great clusters of galaxies. It is the most fundamental motion of the universe. Feel it now. Let go of the picture of a static, solid sky. Replace it with this new image, a gentle, persistent, and perfectly uniform stretching. It is a motion so vast, so slow, so all-encompassing that for most of human history, we were completely unaware of it. We were like microscopic beings living on the skin of a slowly inflating balloon, unable to perceive the curvature or the stretch. We saw only our immediate neighbors, and the space between us seemed fixed. But the clues were there, hidden in the light. The light from the most distant galaxies, those leaves farthest down the river, arrives tired and stretched. It has been carried on the current of expanding space. Its own waves pulled longer and flatter, shifting its color to the red end of the spectrum. It is a cosmic sigh, the sound of light that has traveled for billions of years across a growing universe. As you settle deeper into your rest, let this idea settle into you. The stillness you perceive in the night sky is an illusion, but it is a beautiful one. It is the illusion of perspective. You are not separate from this motion. Your body, your room, your planet, your galaxy. You are part of this gentle, cosmic expansion. You are a passenger on a leaf, floating down the slow, dark river of space. The feeling is not one of chaos or violence. It is a feeling of serene, quiet unfolding, like a flower opening its petals in slow motion, like the steady, silent growth of a great tree. The universe is not falling apart. It is simply becoming larger. It is making more room for itself. Rest in this thought. Let the rhythm of your breath merge with this cosmic rhythm, the slow inhale and the slow exhale, the gentle, persistent stretching of your own lungs and the gentle, persistent stretching of the universe. In this shared motion, there's a profound connection. You are breathing with the cosmos. You can feel this quiet, persistent stretching now, a secret pulse in the darkness. For so long, we believed another force, a great cosmic pull, was the only story of the night. We called it gravity, the shepherd of the stars, the architect of worlds. But this gentle push has also been here, waiting in the silence for you to notice. And in the chapters to come, we will listen more closely to that pull, only to find the even deeper mystery of the push that now seems to be winning. For now, just rest. Float on the river. The night is just beginning. Breathe in the quiet of your room. Feel the gentle, persistent rhythm of the universe we discovered in our last thoughts together. The slow, silent stretching of space itself. It is a motion so vast it feels like stillness, a current so deep it feels like peace. Hold that thought, that feeling of the universe softly expanding, and now, let your awareness drift to something else, something closer. Feel the gentle but firm pressure of your body against the mattress. Feel the comforting weight of the blankets resting upon you. This feeling, this simple, ever-present sensation of being held, is your most personal connection to the other half of our story. This is gravity. Imagine gravity not as a force that pulls, but as an embrace. It is the universe holding itself together. It is the Earth's arms wrapped around you, keeping you from floating away into the coldness of space. It is the reason the air you are breathing right now, this invisible ocean of nitrogen and oxygen, doesn't simply wander off into the cosmos. It is held here, a shimmering, life-giving bubble, by the same gentle embrace that holds you to your bed. This embrace is the first physical law you ever learned, long before you had words for it. It is in the effort of your first attempt to stand and the surprise of your first fall. It is so constant, so fundamental, that most of the time you don't even notice it. It is a silent partner in your every movement, the unseen anchor that gives your world its shape and its substance. It is the reason a cup falls down and not up, the reason rain seeks the ground, the reason roots grow deep into the soil. Let your mind wander through your home. See the dust motes illuminated in a stray beam of moonlight, dancing in a slow, lazy ballet. Eventually, they will come to rest, settling on the floor, a bookshelf, a windowsill. They are answering the quiet call of gravity's embrace. Think of the water in the pipes, waiting patiently behind the tap, held there by the same law that dictates the shape of a single drop. It is a force of order, of place, of things finding their natural level of rest. Now, let's allow this feeling to expand. Your home is held to the surface of a vast, spinning sphere. The Earth's embrace is so powerful it can hold oceans in their basins and mountains upon its crust. It is a patient, tireless embrace that has been here for more than 4 billion years. And this embrace extends further. Look up again in your mind's eye, past the roof and into the night. You see the moon, a silent, luminous pearl hanging in the darkness. The moon is not fixed there. It is in a constant state of falling, perpetually tumbling toward the earth. But it is moving sideways so quickly that it continuously misses, tracing a perfect, repeating arc through space. It is held in the outer edges of Earth's embrace, a celestial dance partner in a waltz that has lasted for eons. The moon, in turn, has its own embrace. It pulls gently on the earth, and the great oceans respond. The tides, the slow, mighty breath of the sea, are the evidence of the moon's touch. It is a conversation, a mutual holding across 250,000 miles of empty space. This is the nature of gravity. It is not a one-way command, but a universal dialogue. Every object that is substance, that is mass, calls out to every other object. The earth pulls on you, but you, in your smallness, pull back on the earth with an equal and opposite force. The sun, that colossal furnace at the center of our solar system, holds the earth in its own powerful embrace, keeping us in a perfect, life-giving orbit. But the earth and all the other planets pull back on the sun, keeping it steady, keeping the whole system in a state of delicate, beautiful equilibrium. For billions of years, this gentle, persistent, and cumulative embrace has been the universe's master architect. After the initial flash of the Big Bang sent everything flying outwards, gravity began its slow, patient work. In the vast, thin clouds of primordial hydrogen and helium, tiny variations existed, pockets that were, by sheer chance, a fraction denser than the space around them. Gravity's embrace is weak from a distance, but it is infinitely patient. It began to gently tug on these denser regions, drawing more and more gas toward them. Imagine a cosmic shepherd, patiently gathering a vast, scattered flock. Over millions of years, the clouds grew denser. The embrace tightened. The pressure and temperature at their cores began to climb, until a point of incredible transformation was reached. A star was born, ignited by the sheer force of gravity's squeeze. The first lights in the universe were switched on one by one, all thanks to this patient, relentless gathering. Gravity did not stop there. It herded these newborn stars together, pulling them into vast, swirling cities of light we call galaxies. Think of the images you have seen of them. The beautiful, spiraling arms of galaxies like our own Milky Way are the visible evidence of gravity's artistry, like the pattern left by a spinning dancer's dress. It gathered these galaxies into even larger families called clusters and wove those clusters into long, shimmering filaments, creating a vast cosmic web. All the structure, all the beauty, all the order you see in the universe is a monument to the patient, constructive power of gravity's embrace. For a very long time, we thought this was the only story that mattered on the grandest scales. The universe began with an outward push, but gravity was always there, working to slow it down, to pull things back together. The most important question in cosmology was a simple one: which force would win? We imagined two possible futures for the universe, both dictated by the strength of this embrace. If the embrace was strong enough, if there was enough substance, enough mass in the cosmos, it would eventually halt the expansion entirely. The outward flight of the galaxies would slow, stop, and then reverse. The universe would begin to contract, pulling all of creation back together in a final, fiery reunion, a big crunch. The embrace would become an inescapable bind. If, on the other hand, gravity's embrace was not quite strong enough, the universe would continue to expand forever. but it would always be slowing down, like a ball thrown skyward, losing its momentum with every passing second. The galaxies would continue to drift apart, but at an ever-decreasing rate. The universe would grow dark, cold, and quiet as the stars burned out one by one. For decades, these were the only two endings we could imagine: a fiery collapse or a slow, fading freeze. The entire fate of the cosmos rested on measuring the precise strength of gravity's embrace. It was a hero of the story, the only force that seemed to shape the universe's ultimate destiny. So feel it again, this constant, comforting presence. It is in the ground beneath you, the air around you, the moon above you, and the distant, swirling galaxies. It is the force of connection, of structure, of home. It is the great cosmic architect, the patient shepherd, the universal embrace. For so long, we thought this embrace was the only story, a slow, inevitable coming together. But what if something is teaching the universe to let go? Settle back into the darkness, into the comfortable weight of gravity's embrace. Feel that steady, calming pull that holds you, that holds the moon in the sky, that gathers the stars into shimmering cities of light. For a time, this embrace was the only story we knew, the grand narrative of a universe held together by its own affection. But now I want you to listen, not with your ears, but with your mind. Listen past the silence of your room, past the sleeping sound of your home, past the rustle of the wind in the trees. Listen for something else, a secret hidden in the starlight. For centuries, the light from the stars was simply for seeing. It was a guide for sailors, a map for farmers, a source of wonder for poets. But in the last century or so, we built new kinds of eyes, giant telescopes, housed in silent, silver domes on remote mountaintops, in the cold, thin air where the sky is clearest. Think of these places now. Imagine profound quiet of a mountain peak at midnight, the sky bursting with more stars than you have ever seen. The air is sharp and clean. Inside the dome, a colossal machine moves with near-silent grace, a giant ear pointed toward the heavens, ready to listen to the ancient stories told by the light. In these temples of science, astronomers were not just looking at the stars. They were listening to them. They were learning to read the language of light. To understand this language, think of light not just as a stream of brightness, but as a wave. Like a ripple spreading across the surface of a perfectly still pond, light travels in waves. Some waves are short and energetic, like the ripples from a pebble dropped from high above. We see these as blue or violet light. Other waves are long and languid, like the gentle swells on a calm sea. We see these as red or orange light. And just like the sound of a bell has a specific, clear tone, the light from a star has a specific signature. The elements burning in that distant furnace, the hydrogen, the helium, the carbon, are like cosmic tuning forks. They absorb and re-emit light only at very specific frequencies, very specific colors. When we look at a star's light through a prism, we don't see a smooth, unbroken rainbow. We see a rainbow with fine, dark lines running through it, like a barcode. These are the spectral lines, the unique fingerprint of that star's chemical makeup. This is its voice, its unchanging song, sung across trillions of miles of empty space. In the early 20th century, patient astronomers like Vesto Slipher began to listen to the songs of faint, fuzzy patches in the sky. At the time, they were called spiral nebulae, and we weren't sure what they were. Were they small clouds of gas within our own Milky Way, or were they something else entirely? Slipher spent countless nights dedicating hundreds of hours of exposure time, just to capture enough of their faint light to read its signature. And as he did, he found something deeply strange. When he looked at the light from these distant, swirling clouds, he found the familiar fingerprints of the elements. But they were not where they were supposed to be. The entire barcode, the entire song, was shifted. And for nearly every nebula he observed, the shift was in the same direction, toward the lower, longer, redder end of the spectrum. Imagine the sound of a train whistle as it passes you. As the train approaches, the sound waves are compressed and the pitch is high. As it speeds away from you, the sound waves are stretched out and the pitch drops lower. You know this sound. It is a universal experience of motion. This stretching of waves is called the Doppler effect. The astronomers were seeing the Doppler effect written in starlight. The light waves from these distant galaxies were being stretched, their pitch lowered, their colors shifted towards red. This is the cosmic redshift. It was a stunning discovery. It was as if the universe was singing a low, melancholic note. It was the sound of things moving away. Slipher had discovered that these spiral nebulae, which we would soon come to understand were entire galaxies just like our own, were rushing away from us at incredible speeds. Listen closely, past the silence of your room. You can almost hear it now. It is not a sound that travels through the air, but a hum that resonates in the very fabric of space. It is the faint hum of the redshift. It is a collective sound 100 billion galaxies all whispering goodbye. This is the moment that our cozy, static universe began to dissolve. The sky was no longer a fixed and painted dome, but a place of profound and universal motion. A few years later, another astronomer, the remarkable Edwin Hubble, took the next monumental step. Using a new, more powerful telescope on another California mountaintop, he was able to measure not just the speed of these galaxies, but also their distance from us. And when he plotted his results, a breathtaking pattern emerged. He saw that the farther away a galaxy was, the faster it was moving away from us. It was an astonishingly clear and simple relationship. A galaxy twice as far away was receding twice as fast. A galaxy 10 times as far away was receding 10 times as fast. This was not the signature of a chaotic explosion, with pieces flying randomly in all directions. This was something more orderly, more fundamental. This discovery turned our quiet sky into a sky in motion. Imagine you are in the center of a vast, dark room, and every wall is moving away from you. You might think you are in a special, rejected place. But now, imagine you are a single raisin in a loaf of raisin bread that is rising in the oven. From your perspective, every other raisin is moving away from you. The raisin next to you moves away slowly. A raisin on the far side of the loaf moves away much faster. But you are not at the center. Every raisin in the loaf would see the exact same thing. The bread itself, the space between the raisins, is what is expanding. This is what Hubble had discovered. We are not at the center of a great cosmic exodus. We are simply one galaxy among billions, all embedded in the fabric of a universe that is stretching everywhere at once. Your mind drifts along with them now, floating on this first, gentle current of expansion. The redshift is not the sound of galaxies running away from us. It is the sound of space-time itself expanding, carrying the galaxies along for the ride. This was a revelation that changed everything, and yet, in a strange way, it felt right. It was the echo of a beginning. If everything is moving apart now, it means that in the past, everything must have been closer together. If you rewind the cosmic clock, all the galaxies rushed back toward each other until, some 13.8 billion years ago, everything in the entire observable universe was crushed into a single, unimaginably hot and dense point. The expansion of the universe was the first great proof of the Big Bang. So the night sky you see in your mind is no longer still. It is breathing. It is unfolding. The silence is not emptiness. It is filled with a deep, red-shifted hum of ongoing creation. The darkness is not static. It is a flowing river, carrying everything with it. This first whisper of expansion was a monumental discovery, a new story for the cosmos. For a while, it seemed to complete the picture. The universe was born in fire and has been expanding and cooling ever since, with gravity's embrace patiently working to slow it all down. It was a beautiful, compelling narrative, but this was only the first whisper. An even deeper secret lay hidden within this motion, a secret that would only be revealed when we learned to measure the expansion with extraordinary precision. The universe was not just expanding. It was doing something no one expected, and that surprise would change our story once more. Rest here for a moment, floating in the gentle current of the expanding cosmos. The low, red-shifted hum of departing galaxies is the new silence, the background music of our universe. We have learned that we live not in a static, painted dome, but in a sky alive with motion. The story we tell ourselves about this motion is important. The words we use, the pictures we paint in our minds, can shape how we feel about our place in this grand design. The name we have given the beginning of this motion is the Big Bang. It is a dramatic name. It conjures an image of firework, a colossal explosion in the dark, a violent, chaotic event that flung matter across a pre-existing void. For many, this is the picture of our creation, a moment of cosmic violence, of shattering and scattering. But tonight, we are going to set that image aside. We are going to replace it with something softer, something more organic, and perhaps something closer to the truth. Think of the universe as a flower, not a firework. The firework metaphor is misleading because an explosion happens at a single point in space and expands through space. But the beginning of our universe was not an explosion in space. It was the beginning of space itself. Before that moment, there was nowhere for an explosion to happen. There was no empty stage for the drama to unfold upon. The entire stage, the actors, and the script all came into being in that first instant. You are not living on a piece of shrapnel flying through an ancient, dark void. You are living inside the firework itself, long after the initial flash, as the glowing embers continue to drift apart in a beautiful, fading display. But even that image doesn't quite capture the grace of it all. So let's return to our flower. Imagine the entire universe, all of space and time, all the matter and energy that would ever exist, contained within a single tiny, perfect bud. It is a point of infinite potential, holding the blueprint for every star, every planet, every living thing, folded tightly within itself. The beginning, then, was not a shattering, but an opening, a slow, graceful unfurling. The expansion of the universe is the bloom of this cosmic flower. In the first moments, the petals began to open, space itself swelling outwards, creating the very dimensions we now inhabit. This expansion wasn't centered on one point. It happened everywhere at once. Every point in the bud began to move away from every other point as the flower itself grew. This is why when we look out into the night sky, we see all distant galaxies moving away from us. Not because we are the center, but because we are one point on one petal of this blooming flower. An observer on any other petal, in any other galaxy, would see the exact same thing. Feel this image in your mind. The motion it inspires is not one of violence, but organic, patient growth. The universe is not a chaotic accident. It is an unfolding, following a set of profound and beautiful rules, the laws of physics that act as its genetic code. These rules ensure that the bloom would be orderly, that its energy would congeal into matter in predictable ways, that this matter would form the intricate structures we see today. The spirals of the galaxies are the whorls on the petals of this flower. The great cosmic web of galaxy clusters is its beautiful, complex anatomy. You feel your own awareness expanding with it, making room for this new and beautiful idea. Let go of the chaos of the firework and embrace the serenity of the bloom. This changes how you relate to the cosmos. You are not a lost fragment from a cosmic detonation. You are part of a living, growing, and breathtakingly elegant structure. You are a conscious part of the universe's own blossoming. As you lie here, breathing in and out, you are participating in this patient unfolding. The universe is not something that happened a long time ago. It is something that is happening right now, in every moment. The space in your very room is part of this bloom, though the familiar embrace of gravity, the force we felt in Chapter 2, is strong enough here to hold the walls of your room together, to hold you together, creating a small, stable sanctuary within the grand expansion. For a long time, this was our most complete picture. The universe bloomed, and the loving, patient embrace of gravity worked against the bloom, gently trying to pull the petals back together. The story of the cosmos was the story of this tension, the outward force of the initial bloom versus the inward pull of gravity. We were living in a universe that was gracefully slowing down, its initial, rapid unfurling giving way to a more stately and measured pace, like a flower reaching the fullness of its bloom. All of our efforts, all the work of those great telescopes on the lonely mountaintops, became focused on one single task, to measure the precise rate at which the bloom was slowing. By measuring that, we could determine the final fate of the flower. Would gravity's embrace be strong enough to eventually make the flower close back on itself? Or would the bloom continue forever, its petals drifting ever outward into a cold and silent future? This was the question. We thought we were simply filling in the final details of a story we already understood. We were building new kinds of eyes, new ways of measuring the cosmos, to watch this beautiful bloom unfold and record its elegant, slowing grace. But the universe, like any great flower, held profound surprise deep within its heart. To see it, we would need to look for our own lighthouses in the deep, cosmic sea. We would need to find stars that could act as perfect mile markers on the petals of the bloom. And when we found them, and when we measured their light, they would tell us a story that no one was prepared for. They would show us that the flower was not slowing down. Its graceful unfurling was, for some reason we cannot explain, beginning to speed up. For now, rest in this image. See the universe not as a field of cosmic debris, but as a garden. You are safe within its bloom. The night sky above you is a vast, open flower, and you are here, now, a witness to the impossible, silent, and ever-growing beauty. Of course, having established our new image of the cosmos, it is time to seek out the lights that will allow us to measure its beautiful, mysterious growth. Let our journey take us out into the deep, in search of cosmic lighthouses. Rest within the petals of our blooming universe. The cosmos is not a chaotic wreck, but a place of graceful, ordered unfolding. We are living within the slow, silent act of creation. And with this new, gentler picture in our minds, a great question emerged, a question that occupied the hearts and minds of astronomers for decades. How fast is a bloom unfolding? And is it, as gravity's embrace would suggest, slowing down? To answer this, you need to be able to measure the universe. But how do you measure a garden of this scale? How do you map a bloom that is billions of light years across? The challenge is one of distance. When you look into the night sky, you see a flat tapestry of light. A star might appear dim because it is truly small and faint, like a candle. Or it might be a colossal, brilliant star that only appears faint because it is immensely far away, like a bonfire on a distant mountain peak. Disentangling the two, a star's true brightness from its apparent brightness, is one of the hardest problems in astronomy. To solve it, you need a special kind of object. You need something whose true brightness is already known. You need a standard candle. Imagine you are standing on a dark shore, looking out a foggy sea. You see a faint light. You don't know if it's a small boat nearby or a huge ship far away. But now imagine you know that every lighthouse in this sea uses the exact same standardized 1,000-watt bulb. Suddenly, you can tell the distance. By how dim the lighthouse appears, you can calculate with great precision how far away it is. The dimmer the light that reaches you, the farther it must have traveled. To measure the cosmos, to map our blooming flower, we needed to find lighthouses in the deep. We needed to find a celestial event that was, in essence, a standard candle, an explosion so predictable, so uniform, that its true brightness was always the same, no matter where or when it occurred in the universe. And we found it in the final dramatic act of a certain kind of dying star. Our journey tonight takes us in search of one of these stars. Let your mind drift from the earth, past the moon, out of the comforting embrace of our own solar system. We travel out into the swirling river of stars that is our Milky Way galaxy. Most stars you see are living out their lives in a state of calm equilibrium. But we are looking for a star that has already died. We are seeking a ghost. After a star like our sun has burned through all its fuel, it doesn't explode. Its life ends not with a bang, but a sigh. It puffs its outer layers away into space, creating a beautiful, glowing nebula, like a final, colorful breath. And at its center, the hot, dense core remains. This core is called a white dwarf. Imagine an object the size of our planet Earth, but with a mass of an entire sun packed inside it. It is a single cosmic diamond, a crystalline ember left over from a stellar fire, now slowly, over trillions of years, cooling and fading into blackness. These white dwarfs are common in the universe, the quiet ghosts of suns long past. In their solitude, they are peaceful. They are not our lighthouses. But many stars do not live alone. They are born in pairs, locked in a gravitational dance that can last for billions of years. Let us travel now to one such pair. In your mind, you see a large, vibrant star, still in the prime of its life, its surface churning with energy, and orbiting it, you see its smaller, quieter companion, a white dwarf. The dance of these two stars is not entirely equal. The white dwarf, for all its smallness, is incredibly dense. Its gravitational embrace is immense, and so it begins a slow, silent act of celestial theft. It starts to pull material from the outer layers of its larger, living companion. You see a shimmering stream of gas, a river of incandescent hydrogen, being pulled from the larger star and spiraling down onto the surface of the white dwarf. It is a breathtaking sight, a silent, glowing waterfall connecting two stars. For millions of years, this continues. The white dwarf, the stellar ghost, is feeding. It wraps itself in the stolen gas from its partner, and its mass begins to grow. It becomes heavier, and its gravitational embrace becomes even stronger, pulling the material in faster. But this process cannot go on forever. There's a limit to how heavy a white dwarf can become. A brilliant physicist named Subramanian Chandrasekhar calculated this limit, while on a long sea voyage from India to England, he discovered that if a white dwarf, supported only by the strange laws of quantum mechanics, exceeds about 1.4 times the mass of our sun, it can no longer hold itself up. Its own gravity becomes overwhelming. This is the Chandrasekhar limit, a fundamental boundary in the lives of stars. Our white dwarf, patiently gathering material from its companion, is approaching this limit. It now sits precariously on a cosmic knife's edge. The addition of just a little more material, one final sip from the stellar river, will be enough to push it over the edge. And when it happens, the result is spectacular. The core of the white dwarf, unable to support the immense weight, begins to collapse. The pressure and temperature skyrocket to billions of degrees in less than a second, a wave of thermonuclear fusion. The same process that powers living stars, but in a wild, runaway form, ignites the entire star almost instantly. The result is a supernova, an explosion of such colossal energy that for a few weeks, this one single dying star will outshine its entire host galaxy of 100 billion stars. This is our lighthouse, finally switched on, and it is the perfect lighthouse. Because every single one of these events, which we call a Type Ia supernova, happens in the exact same way. They all ignite when they reach the exact same mass, the Chandrasekhar limit. And because they all start with the same amount of fuel and ignite in the same way, their true brightness, their intrinsic luminosity, is always the same. They are perfect standard candles. Now we have our tool. We can look out into the deep cosmic ocean and find these brief, brilliant flashes of light. When we see one, we know exactly how bright it truly is. By measuring how dim it appears to us, we can calculate its distance with incredible precision. We have found our lighthouses in the deep. With this new power, two teams of astronomers began an epic quest. They would scan the skies night after night, looking for these fleeting supernovae in the most distant galaxies imaginable. Their plan was simple and elegant. They would use these lighthouses to create a map of our blooming universe, measuring the distances to galaxies near and far. By comparing the distances to the redshift, the speed at which the galaxies were moving away, they could chart the history of cosmic expansion. They knew what they expected to find. They expected the most distant lighthouses, the ones whose light had traveled for billions of years to reach us, to appear slightly brighter than expected. This would be the sign that the universe's expansion was slowing down, just as everyone thought. The light from these distant stars would have had a shorter, faster journey in a younger universe that was expanding more quickly. This was the goal, to measure the gentle, graceful slowing of the cosmic bloom, to confirm the story we thought we already knew. But the universe had a different story to tell, and the ancient light from these distant, dying stars, these perfect lighthouses, carried a message that would shatter our understanding of the cosmos forever. Breathe deeply and settle into the quiet of this moment. In our journey, we have found our perfect lighthouses, the brilliant, fleeting flares of dying stars. We know their true wattage, their standard brightness. By seeing how dim their light appears when it finally reaches our telescopes, we can tell how far away they are, a true measure of distance across the vast, blooming flower of a universe. But distance is only one half of the story. To understand the history of the cosmic bloom, we also need to know the speed at which the petals are unfurling. To do this, we must become listeners once again. We must learn to measure the echoes of light, to understand the secrets that a simple beam of starlight carries with it across the eons. The light from these distant stars carries a secret. It travels as a wave, a vibration in the very fabric of reality. Imagine launching a tiny boat with a perfectly regular, repeating wave pattern trailing behind it on a calm lake. Now, imagine the lake itself begins to stretch, the water molecules themselves moving apart. The little boat will continue on its journey, but the waves it leaves behind will be stretched out, their crests pulled further and further apart by the expansion of their medium. The wave itself is a record of the journey it has taken. So it is with light. A photon, a single particle of light, is born in the heart of a supernova, a brilliant flash millions of light years away. It begins its journey across the cosmos. For all those years, as it travels through the deep, it is carried on the current of expanding space-time. The universe is stretching, and so the light wave itself is stretched along with it. The longer its journey, the more it is stretched. This stretching is a gentle, pervasive process. It is the sigh of the cosmos, and it leaves a clear, measurable signature on the light itself. Remember the colors of the rainbow. The spectrum of light, blue and violet light, are made of short, energetic waves. Red and orange light are made of long, lazy waves. When a light from a distant supernova is stretched by cosmic expansion, its waves become longer. Its color signature shifts towards the red end of the spectrum. This is a redshift we have spoken before, but let us feel it now in a new way. Think of it not just as a color change, but as an echo. Imagine the supernova is a great bell, struck once in the distant past. Its brilliant flash is a sound, a complex chord made of many different notes. We know the exact notes this bell should play. We know this because the explosion creates specific elements: silicon, calcium, iron, and these elements, like cosmic tuning forks, ring with very specific frequencies of light. We have seen this pattern, this unique spectral barcode, in supernovae that are close to us. We know the original song by heart. Now imagine that song traveling to you not through air, but through a strange, stretching medium. The melody will remain the same, but every note will be shifted down to a lower, deeper register. A sharp, clear piccolo solo would arrive, sounding like a mournful cello. The tune is recognizable, but the tone has been changed by the journey. This is what happens to the light. The pattern of spectral lines is identical, but the entire pattern has been transposed. It arrives deeper, softer, redder. It is the echo of a brilliant shout, softened by time and distance into a gentle sigh. This is a redshift. It is a peaceful measure of a universe in motion. The amount of stretching, the degree to which the light has been redshifted, tells us exactly how much the universe has expanded since that light began its journey. And this, in turn, gives us the speed of the galaxy's recession. So now we have our two perfect tools. The supernova's apparent dimness tells us its distance, how far the light has traveled. The light's redshift tells us its speed, how much space has stretched during its journey. We have a cosmic map and a cosmic speedometer. The astronomers on those lonely mountaintops had everything they needed. Let this process connect to you now, in the quiet of your rest. Feel the slow, steady rhythm of your breathing. A gentle expansion as you inhale, a soft release as you exhale. Your chest rises and falls in a simple, peaceful cadence. Feel this stretching in your own body. This is the same kind of gentle, rhythmic motion. The universe is breathing, and its breath is the expansion of space. The redshift is the sound of its long, slow exhalation. There is no violence in this stretching. There is no tearing. It is a fundamental property of our reality, as natural and as effortless as your own breathing. As you lie here, you are participating in this cosmic rhythm. Your own small, personal space is stable, held together by the familiar forces of electromagnetism and gravity. But you are embedded in a universe where the grand spaces, the great voids between the petals of the cosmic flower, are constantly, peacefully stretching. The light that travels through them carries a memory of this stretching, a soft echo that we can now, finally, read. The teams of astronomers began their work in earnest. They would find a distant supernova and perform these two measurements. First, they would measure its redshift to find its speed. Based on that speed, and on the old story of a slowing universe, they would predict its distance. Then, They would measure its brightness to find its actual distance. They knew what they should find. For the most distant supernovae, the light should have traveled a shorter distance than their speed would imply. This is because, in a slowing universe, the expansion rate was faster in the past. The journey would have been quicker. The lighthouse would appear brighter than expected for its redshift. This was a clear, unambiguous signature of a universe whose bloom was slowing down, pulled back by the relentless, familiar embrace of gravity. They plotted their points on a graph. On one axis, distance. On the other, speed. Each new supernova was a new dot of light, a new piece of the puzzle. They were charting the history of the cosmos. And as the data came in, as the dots began to form a pattern, a deep and unnerving silence must have fallen over those mountaintop control rooms. The echoes were not telling the story they expected. The lighthouses were not behaving as they should. The universe, it seemed, was not slowing down at all. Of course, the stage is set, the tools are in hand, and the ancient light from dying stars has reached us. Let us now witness the moment when the universe revealed its most profound and unexpected secret. Settle into the quiet of this moment. Let your breath be slow and even. We are standing on the precipice of a great discovery, a moment that would change our understanding of everything. Imagine yourself in the cool, still air of a mountaintop observatory. The great telescope has done its work, gathering the faint, ancient light from a supernova that exploded billions of years ago in a galaxy you will never see. The data flows like a silent stream onto a computer screen. A new point of light is about to be added to a chart that holds a history of the universe. The two teams of astronomers, working on opposite sides of the world, were plotting this chart. On one axis, distance, derived from predictable dimness of their standard candle lighthouses. On the other axis, speed, derived from the gentle stretching of light we call redshift. Every new supernova was another point, another piece of the story. They knew the story they were supposed to find. For nearly a century, our understanding of the cosmos had been shaped by the elegant tug-of-war between two great forces. The initial outward momentum of the Big Bang, the unfurling of the cosmic bloom, was constantly being restrained by the inward pull of gravity's embrace. Every piece of matter, every star, every galaxy, every wisp of gas, was pulling on every other piece. Therefore, the expansion of the universe must be slowing down. It was the most sensible, logical, and inevitable conclusion. Their chart should have been the proof. The most distant lighthouses, the ones whose light had traveled the longest to reach us, should appear slightly brighter than their speed would imply. They were showing us a younger universe, a universe that was expanding much faster than it is today. They were giving us a snapshot of a time when the cosmic bloom was fresh and fast, before gravity had billions of years to apply its gentle, persistent brake. This was the clear signature they were looking for. Each new data point from a far-flung supernova should have confirmed it, but it did not. As the point began to populate the chart, a deep, unnerving puzzle emerged. The most distant supernovae were not brighter than expected. They were dimmer, fainter. They were farther away than they were supposed to be. At first, it was easy to dismiss. Perhaps there was some interstellar dust in the way, making the supernova appear dimmer than it really was. Perhaps the chemical composition of these older supernovae was slightly different, making them intrinsically less powerful lighthouses. The scientists, methodical and cautious, spent months, even years, trying to find their error. They were trying to prove themselves wrong, because the alternative was unthinkable. It was like throwing a set of keys into the air and watching them accelerate towards the ceiling. It was like a ball rolling down a hill, suddenly deciding to speed up instead of slow down. It violated the entire story of the universe as they knew it. But the data was stubborn. Both teams, using different methods, different telescopes, and looking at different supernovae, found the exact same thing. The farther they looked back in time, the more profound the effect became. The lighthouses were undeniably, systematically too faint. There was only one conclusion that could be drawn, a conclusion so staggering that the scientists themselves could hardly bring themselves to believe it. The journey of the light from these distant supernovae had taken longer than expected. The universe had stretched more than expected during the light's journey. The only way this was possible was that the expansion of the universe was not slowing down. It was speeding up, Let that thought sink into you, not with alarm, but with a sense of profound wonder. The universe is in a hurry. For the first several billion years after the Big Bang, gravity was indeed winning the cosmic tug-of-war. The expansion was slowing down just as everyone thought. But then, something changed. About 5 billion years ago, a new influence began to take over. A mysterious, repulsive force began to overwhelm gravity's embrace. The gentle river current of expansion, which had been meandering and slowing, became a silent, deep-sea accelerator. The blooming flower of the cosmos, which should have been reaching the fullness of its unfurling, instead began to open faster and faster. This is the secret the lighthouses revealed. This is the surprise that was waiting for us in the dark. We live in a runaway universe. Feel this impossible quickening now, not in your mind, but in your body. Turn your awareness to the quiet, steady pulse of your own heart. Feel the gentle, rhythmic beat in your chest or your wrist. It is a slow, reliable cadence, the fundamental rhythm of your own life. Now, imagine that without any reason, without any exertion on your part, you could feel that pulse begin to subtly quicken. Not a panicked, racing heart, but a deep, powerful, and mysterious acceleration in your own core rhythm. A sense that the very engine of your being was revving up, pushed by an unseen hand. That is the feeling that this discovery gave to us. A change in the fundamental rhythm of the cosmos. Our universe, our home, is not heading toward a quiet, stately old age, nor a fiery collapse. It is heading somewhere else entirely, driven by a force we had never even imagined. The story of our universe was no longer a simple two-act play between an initial push and a final pull. A third character walked onto the stage, a character that had been there all along, hiding in the shadows, waiting for the universe to grow large enough for its influence to be felt. This character does not pull, it pushes. It does not gather, it scatters. It does not create structure, it works to dissolve it by pushing everything apart at an ever-increasing speed. This discovery did not provide an answer. It created an immense and beautiful question that hangs over all of modern cosmology. It rewrote the story of space, of time, and of our ultimate fate. What is this mysterious energy? Where does it come from? Why did it begin to dominate the universe only in the latter half of its life? We had to give this profound new mystery a name that would reflect its enigmatic nature, a placeholder for our own deep lack of understanding. And that name is the beginning of the next, even deeper, part of our journey into the quiet heart of the night. Of course, we have arrived at the edge of a great mystery, the unexpected hurry of the cosmos. Now, it is time to give that mystery a name and to understand its quiet, pervasive nature. Breathe in and breathe out. Settle into the feeling of this moment, this quiet sanctuary you have created for yourself. In our journey, we have arrived at a place of profound surprise. We have learned that the beautiful, blooming flower of our universe is not slowing down, but opening faster and faster, its petals accelerating into an unknown future. This discovery left a vast silence in our understanding, a space where our old story used to be. And into that silence we had to speak a new name. We give the mystery a name, dark energy. It is a name that might sound imposing, even a little frightening. The word dark can conjure images of things that are hidden, sinister, or unknown. The word energy speaks of power and force. But tonight, we will learn that this name is not meant to inspire fear. It is a name born of humility. It is a simple label for a mystery, a placeholder for one of the deepest questions we have ever had to ask. Let us first understand what dark means to a scientist, to an astronomer. It does not mean evil. It does not mean monstrous. It simply means that it does not interact with light. You are in a dark room right now, but the darkness is simply the absence of light. Dark energy is something different. It is a substance, a presence, that light passes through as if it weren't there at all. It does not shine like a star. It does not reflect light like a planet or a moon. It does not even block light or cast a shadow like a cloud of dust. It is utterly, completely transparent. It is dark to us in the way a perfectly clean pane of glass is invisible, or the air you are breathing is invisible. You only know it is there by its effect on everything else. So do not picture a monster or a malevolent force. Instead, think of it as a presence in the emptiness. It is the answer to a question we never thought to ask. What is the nature of nothing? For most of human history, we have thought of the vacuum of space as just that, a vacuum, an empty, passive container in which the real story of stars and galaxies unfolds. But dark energy tells us something different. It suggests that the vacuum itself, the very fabric of space-time, has an intrinsic, fundamental energy woven into it. Every tiny portion of so-called empty space is humming with a faint, residual power. Imagine the air in your room. Now imagine that the air itself, not a radiator or a blanket, had its own faint, uniform warmth, a gentle, constant energy that belonged not to any object in the room, but to the space of the room itself. This is our best understanding of dark energy. It is not something in space. It is the energy of space. And this energy has a very strange property. Unlike gravity, which pulls, this energy has a kind of negative pressure. It pushes. It is a quiet, pervasive, and constant outward push. Here is the most remarkable part of the story. As the universe expands, as the cosmic bloom unfurls, more space is created. And because this energy is a property of space itself, as more space comes into being, more of this energy comes into being along with it. Think of it this way. If you have a lamp in a room, and you make the room bigger, the light from the lamp spreads out and becomes dimmer. This is how normal matter and energy behave. The more the universe expands, the more diluted and spread out the matter becomes. Gravity's embrace gets weaker as everything gets farther apart. But dark energy is different. It is as if the energy belongs to the volume of the room itself. If you make the room bigger, you have more room, and therefore you have more of this strange energy. More space means more dark energy, which means more outward push. This new outward push creates even more space, which in turn creates even more dark energy. It is a gentle, cosmic feedback loop. It is the reason the universe's expansion is not slowing down, but speeding up. The bigger it gets, the faster it grows. This is why we can think of dark energy as the shadow that shapes the light. While it doesn't cast a shadow itself, it's gentle. Accelerating push is the invisible sculptor of the cosmos on the largest scales. Gravity is the artist that builds the beautiful filaments of the cosmic web, gathering galaxies into great, shimmering walls. But dark energy is the force that determines how fast those walls recede from one another, stretching the entire canvas on which gravity is working. It shapes the overall structure of the cosmos, just as the shape of a valley, carved by an unseen river, shapes the path of the light and shadow across the landscape. And in the same way, it is the silence that gives the cosmic song its form. Think of a piece of music. The notes are important, but so are the rests, the moments of silence between them. The rhythm and feeling of a melody are defined just as much by the spaces as by the sounds. The galaxies, the stars, the planets, they are the beautiful, vibrant notes. But dark energy is the expanding silence between them. Its persistent, growing presence dictates the grand rhythm of the cosmic symphony, a composition that is becoming slower, more spacious, and more minimalist with every passing eon. So let this new understanding settle in you, as peacefully as the darkness of your room. Dark energy is not an intruder. It is a fundamental part of the landscape of reality. It is the faint, steady pulse of the vacuum. It is the gentle breath of space-time itself, an exhalation that is growing deeper with time. It is not a force to be feared, but a presence to be contemplated, a mystery that invites us into a deeper and more profound relationship with the universe. The quiet of your room, the space between you and the walls, is filled with the same energy. It is here, now, a part of your immediate reality. You are floating in an ocean of it, though its effect is so subtle on these small scales that you will never feel it. But it is there, a constant, peaceful, and powerful presence. We have given it a name. We have described its nature as best we can. But how much of the universe is actually made of this strange, invisible substance? When we begin to do the accounting, when we create a recipe for the cosmos and add up all the familiar matter, all the stars and planets, and then add this mysterious new ingredient, we are faced with the most humbling realization of all, and that is where our sleepy journey will take us next. Of course, having given the great mystery a name, let us now try to understand its true place in the cosmos. Let us weigh the substance of the universe, and in doing so, weigh the substance of nothing itself. Take a slow, deep breath, and now let it go. In the pause before your next breath, there is a moment of stillness, a space of pure potential. Think of the silence between two notes of a beautiful melody, or the empty space on a canvas that gives a painting its form and balance. We often think of these spaces, these moments of nothing, as simply empty. We define them by what they lack. But what if they are not an absence, but a presence? What if nothing has a substance all its own? You are floating in the space between thoughts, the space between breaths. This is where dark energy resides. In the latent energy of what we perceive as nothing. This idea, as modern as it seems, has a history. It begins with one of the greatest minds we have ever known, Albert Einstein. When he first formulated his revolutionary theory of general relativity, a new story for gravity, his equations told him something unsettling. They told him that the universe must be dynamic. It must either be expanding or contracting. It could not simply sit still. But in the early 20th century, the prevailing wisdom, the evidence of everyone's eyes, was that the universe was still. It was a static, eternal, and unchanging cosmos. So, to make his beautiful equations match the universe he thought he lived in, Einstein added a new term, a small mathematical fix that would counterbalance gravity's embrace and hold the universe in a perfect, static balance. He called it the cosmological constant. It acted as a kind of anti-gravity, a repulsive force that was an inherent property of space itself, an energy of the vacuum. A decade later, when Edwin Hubble looked through his telescope and discovered the redshift of the galaxies, when he proved that the universe was in fact expanding, Einstein realized this fudge factor was unnecessary. He famously discarded the idea, calling it his biggest blunder, but he may have been too hard on himself. For in his attempt to hold the universe still, he had unwittingly written down the very thing that, a lifetime later, we would need to explain why it is speeding up. His blunder may have been one of his most prescient ideas. He had glimpsed the nature of dark energy, long before anyone knew it existed. This cosmological constant is now our leading description of dark energy, and it suggests that the vacuum is not empty. On the smallest possible scales, far smaller than an atom, the universe is a place of roiling, seething activity. Imagine the surface of the most placid mountain lake. From a distance, it is a perfect mirror, the image of stillness. But if you were to zoom in to a microscopic level, you would see that the water is in constant motion, a chaotic dance of molecules jostling and vibrating. The vacuum of space is like this. Our best theories of quantum mechanics tell us that it is not a quiet void. It is a quantum foam, fizzing with pairs of virtual particles that spontaneously pop into existence, exist for an immeasurably brief moment, and then annihilate each other, disappearing back into nothing. It is a constant frenetic dance of being and non-being. It seems like this activity should all cancel out, that the net energy of this foam should be zero. But it is not. There is a tiny, residual, leftover energy, a net vibration. This is the energy of the vacuum, the energy of nothing. And this is the source of the quiet, pervasive push that is accelerating the universe. This is dark energy. It is a cosmic sigh, filling all of space. Now let's try to grasp its power. Let's create a recipe for our universe, a cosmic inventory of everything that exists. Imagine we have a grand cosmic scale, and we're going to place all the ingredient of reality onto it to see what weighs the most. First, let us add all the things we know and love, all the things you might think of when you picture the universe. Let's gather all the stars, every single one of the billions of suns in our galaxy, and the billions of galaxies beyond. Let's add all the planets, moons, asteroids, and comets. Let's gather every wisp of glowing gas, every beautiful, colorful nebula. Let's add all the normal matter, the atoms and elements that make up you, the air you breathe, the bed you are resting on, everything that shines, reflects, or absorbs light, everything we can see. We place it all on the scale. The result is shocking. All of this, the entire visible universe, accounts for less than 5% of the total mass and energy required to explain the cosmos we live in. It is a humbling realization. All the stars in the sky, all the worlds we could ever hope to visit, All of it is just a tiny bit of froth on the surface of a much deeper, unseen ocean. So what is the rest? Well, scientists have discovered that galaxies are spinning too fast to hold themselves together with the gravity of their visible matter alone. There must be something else there, an invisible substance with a powerful gravitational embrace. We call this dark matter. It is another great mystery, a different kind of darkness. It does not push things apart. It pulls them together. It is the invisible scaffolding upon which galaxies are built. When we add all the dark matter to our cosmic scale, we account for another 25% of the universe. So now we have 5% visible matter and 25% dark matter. That's 30% of the total. What is the remaining 70%? What is the vast, overwhelming majority of the substance of our reality? The remaining 70% is dark energy. The weight of nothing outweighs everything else. The latent, fizzing energy of the vacuum, the gentle, repulsive sigh of space-time itself, is the dominant component of the cosmos. It has more power than all the stars combined. The silent push of emptiness is more influential than the gravitational embrace of all the matter, both seen and unseen. Let that settle into your awareness. Imagine exploring a vast, ancient forest. You spend a lifetime cataloging every single tree, from the tallest redwood to the smallest sapling. You study every animal, every insect, every stone, every river. And after all that work, you come to the conclusion that the weight of the invisible, silent air between all the trees is more than double the weight of the entire forest itself. This is the universe you are living in. You are immersed in its most dominant and most mysterious substance. The space in your room, the quiet void that feels so passive and empty, is a sample of the most powerful and abundant thing in all of creation. It is not something to be dismissed. It is the main character in the story of the cosmos, a character that has been hiding in plain sight, in the spaces between things, all along. And here lies a great paradox, a deep and unsettling whisper that tells us our story is far from complete. When our physicists try to calculate how much energy the quantum foam should have, based on their theories, the number they get is enormous. It is 120 orders of magnitude larger than the gentle, subtle energy we actually observe. The discrepancy between the theoretical weight of nothing and its measured weight is the largest disagreement between theory and observation in the history of science. It is a quiet hint that our understanding of gravity, of space, of time, of nothing and everything is still in its infancy. For now, rest in this beautiful, humbling truth. The universe is mostly made of the gentle, accelerating power of emptiness. And you are right in the middle of it. Of course. Let us take the profound and humbling truth we have just learned and frame it in a new way. Let us enter a cosmic kitchen and discover the recipe that created our reality. Breathe in the quiet of the universe. In our last chapter, we stood before a grand cosmic scale and weighed the contents of reality. We found surprising truth that everything we can see, every star and galaxy, is but a tiny fraction of what truly exists. The great majority is made of unseen, unknown substances. An inventory is a useful thing, but it can also feel cold and abstract. So tonight, let us take that list of ingredients and do something warmer, something more creative. Let us imagine we are baking a cake made of the entire universe. Find a comfortable space in your mind, a quiet cosmic kitchen. The air is still and filled with a gentle potential. On the counter before you is a large mixing bowl, as vast as the night sky. We will now gather our ingredients and combine them, step by step, to create the universe you are resting in tonight. First, we need the flour. This is the most familiar ingredient, the substance that gives our cake its structure and its flavor. This is the ordinary matter, the stuff of atoms. Let us gather it. We take the fine, shimmering dust of ancient nebulae, the ground-down remnants of stars that lived and died long ago. We add the heavy elements forged in the fiery hearts of supernovae, the iron, the carbon, the oxygen. We pour in the vast, cool clouds of hydrogen and helium that drift in the spaces between the stars. This is the flower of you. It is the substance of the earth, the sun, the planets, and all the distant, twinkling stars you can see. It is everything you have ever touched, tasted, or seen. It is beautiful, essential, and precious. We pour our scoop of this precious flour into the vast mixing bowl, and we see that it barely covers the bottom. In the grand recipe of the cosmos, all the visible matter in the entire universe makes up less than 5% of the total ingredients. It is just one small part of our cosmic cake. Now, every good cake needs sugar, but the sugar in our cosmic recipe is a very strange kind. It is completely invisible. You cannot see it or taste it. This is the dark matter. We added to the bowl a much larger portion than the flour, about 5 times as much. The bowl now looks no fuller than it did before, yet it has become much heavier. This dark matter is the secret ingredient that allows the cake to have texture. Its sweetness is its powerful gravitational embrace. It is the invisible crystalline structure that allows the flour of ordinary matter to clump together. Without this dark matter, the flour would just be a loose, unconnected powder. But with it, the flour can gather into patterns, forming the beautiful fruit within our cake, the swirling shapes of galaxies. The dark matter is the invisible web, and the visible matter is like the dew that collects upon it, revealing its beautiful, intricate structure. So we have our flour and our invisible sugar, the seen and the unseen matter, held together by their mutual gravitational pull. Our bowl is now about 30% full of substance, but it is still mostly empty. Now, for the final and most important ingredient. This is the one that makes up the vast majority of our recipe. The remaining 70%. This is dark energy, and it is unlike any ingredient you have ever used. It is not a solid or a powder. It is not a liquid. It is the energy of the emptiness itself. Imagine you are making a delicate meringue. You take egg whites and you whip them, folding air into them, creating something that is light, airy, and voluminous. Dark energy is like this. It is the airiness of the cosmic cake. It is a leavening agent that causes the entire universe to rise. We add it to the bowl, and in an instant, the bowl is full to the brim. The dark energy fills all the spaces between the grains of flour and the invisible crystals of sugar. It doesn't mix with them in the traditional sense. It is the very space in which they exist. It is a substance that has no weight in the way we normally think of it. Yet it is the most massive component of the universe by far. It is a quiet, pervasive lightness that is more influence than everything else combined. And this ingredient has a remarkable property. It causes the cake to continue to expand. Not like a normal cake that rises in the oven and then sets. The cosmic cake is always rising. The airy lightness of dark energy is constantly pushing outward, causing the whole structure to swell faster and faster. The fruit of the galaxies embedded within it are all moving away from each other, not because they're flying to the cake, but because the cake itself is expanding, carrying them along with it. So now, our cosmic cake is complete. It is a strange and wonderful creation. It is mostly made of an invisible, airy, accelerating lightness. Dotted throughout it are invisible crystals of mysterious, heavy sugar. And sprinkled within that, in beautiful, intricate patterns, is the precious flower of the stars, the planets, you and me. As you rest here tonight, you are not separate from this creation. You are inside it. You are a tiny, perfect fleck of the cosmic flower, suspended in this vast, mysterious, and beautiful cake. Feel the lightness of its texture all around you. The space in your room, the space between you and the ceiling, is made of the universe's most dominant ingredient. You are floating in a substance that is both emptier than the most perfect vacuum and more powerful than all the suns in the sky. There is a deep comfort in this. It means that the universe is not a dense, crowded, and violent place. It is, by its very nature, spacious. It is mostly made of a gentle, persistent, and quiet push. It is a reality that values space, that values the silence between the notes. You are resting inside this cosmic cake, feeling the lightness of a mysterious, airy texture. You are a part of a recipe that is grander and stranger than we could have ever imagined. We have combined the ingredients. We understand the proportions. But how do they interact? What is the story of the cosmic dance between the gathering embrace of matter and the expansive, airy lightness of dark energy? That is the next step in our journey. Let your body sink a little deeper into the surface that supports it. Feel the points of contact between you and your bed, a gentle, reassuring pressure. Feel the weight of your limbs, the heaviness of your head on the pillow. This sensation, this constant, familiar feeling of being held, is gravity's embrace. It is a universe pulling you close, keeping you anchored and safe. This is one side of a great cosmic story, a constant pull inward. Now, turn your awareness to the space around you, the quiet air in your room, the vast, silent darkness beyond your walls. As we have learned, this space is not empty. It is filled with a gentle, persistent energy that pushes outward, a quiet but powerful force that seeks to expand, to create more room. This is the other side of the story. The entire history of the universe, from its first fiery moments to this peaceful, quiet night, can be understood as a delicate and grand cosmic tug-of-war between these two fundamental tendencies, the inward pull of gravity and the outward push of dark energy. Imagine, in your mind's eye, a great cosmic balance scale. On one side, we place all the matter of the universe, the flower of the stars and the invisible sugar of dark matter. This side of the scale represents gravity's embrace. It wants to pull everything together, to collapse it all back into a single point. On the other side, we place the airy, expansive lightness of dark energy. This side represents the push, the desire for space to grow. The story of our universe is the story of the scale tipping, slowly and gracefully, over 13 billion years. Let us travel back in time to the young universe. In the first few billion years after the Big Bang, the universe was a much smaller, denser place. The cosmic cake had not yet risen very much. All the matter, all the galaxies and gas, were much closer together. In this crowded, youthful cosmos, gravity had a tremendous advantage. Its embrace was powerful and intimate. The particles of matter were close enough to feel each other's pull strongly. On our cosmic scale, the side representing matter and gravity was weighed down heavily. It was the clear winner of the tug-of-war, and the effect of this was written into the motion of the universe itself. The initial, rapid expansion from the Big Bang was being slowed down and slowed down dramatically. It was as if the universe had a foot on the brake. Every moment, gravity's embrace was working to rein in the expansion, to pull the petals of the cosmic flower back together. For billions of years, this was the state of things. Gravity was the undisputed champion. But as the universe continued to expand, something remarkable began to happen. The matter, both light and dark, became more and more spread out. The galaxies drifted further apart. And as they did, the strength of gravity's embrace between them grew weaker. Gravity is powerful up close, but its influence fades significantly with distance. The matter side of our cosmic scale, though its total weight remained the same, began to lose its leverage. Now, consider the other side of the scale, the side of dark energy. It behaves in a completely different way. Dark energy is a property of space itself. Its power is not diluted by expansion. In fact, its power grows. As the universe expanded, more space was created, and with more space came more dark energy. While the influence of gravity was slowly waning, the total influence of dark energy was steadily, quietly increasing. Imagine two people in a tug-of-war. One is a giant, incredibly strong but slowly getting tired. The other is smaller, but with every passing minute, they are secretly being reinforced by 100 invisible helpers. For a long time, the giant is winning easily, but eventually, the growing collective strength of the other side begins to match the giant's fading power. This is what happened in our universe. For about the first 9 billion years, gravity was a stronger force, and the expansion was slowing down. But then, a tipping point was reached, a moment of perfect, exquisite balance. The weakening inward pull of gravity became exactly equal to the growing outward push of dark energy. For a brief moment in cosmic history, the universe hung in a state of equilibrium. The cosmic tug-of-war was a perfect stalemate, and then the balance tipped. As the universe continued to expand just a little more, gravity's pull weakened further, while the push of dark energy grew even stronger. The side of dark energy on our cosmic scale began to dip lower. The tired giant in our tug-of-war began to be pulled forward. From that moment on, a new era began in the universe, an era of acceleration. We are living in that era now. For the last 5 billion years or so, dark energy has been the dominant force on the largest scales of the cosmos. The foot has been taken off the brake and placed on the accelerator. The expansion is no longer slowing down. It is speeding up, driven by the ever-growing influence of this mysterious push. Feel this cosmic tug-of-war in your own state of rest. Your body feels heavy, held securely by gravity to your bed. On the scale of you, your room, your planet, and even your galaxy, gravity is still the overwhelming victor. The inward pull is what gives you structure, what gives you a sense of place. It is your anchor in the cosmos. You are not flying apart. The embrace that holds you is firm and reassuring. And yet, you are also floating in an ocean of dark energy. The very space you occupy is imbued with this gentle, expansive push. While it is too weak to overcome the bonds of your body or the gravity of the earth, on the grandest scales, it is the new champion. You are living in a perfect, delicate balance. You are a citizen of a realm where gravity reigns supreme, a small, stable island of order. But your island is situated in a vast, cosmic sea that is swelling and accelerating, a sea governed by a completely different power. There is a deep peace in this thought. The universe is not a simple, one-sided story. It is a dynamic and evolving interplay of opposing forces, a dance of push and pull, of gathering and scattering, of embrace and release. And you are here now at a moment in cosmic history where you can feel both. You feel the profound security of gravity's pull, and you can understand the gentle, liberating freedom of dark energy's push. You are held, and you are expanding. You are anchored, and you are free. Rest in this perfect cosmic balance. Of course, having felt the cosmic tug-of-war, let us now turn our attention to the very arena where this contest takes place. Let us explore the true nature of the space around us, the shape of emptiness itself. Breathe in the stillness of your room. Your awareness is calm. Your body is at rest. Let your mind gently scan the space around you. Consider the air between you and the ceiling. Think about the dark, quiet space beneath your bed or the unseen volume within a closet. We call these places empty. We think of space as a stage, a passive, empty container where the drama of objects and matter unfolds. But this is an illusion. The emptiness has a shape. It has a texture. It has a life of its own. Tonight, we will learn to feel the true nature of this space. The space under your bed and the space between the farthest galaxies are connected. They are not different kinds of nothing. They are woven from the exact same extraordinary fabric. This fabric is called space-time. Let us picture it as Albert Einstein first imagined it. Think of a vast, flat sheet of rubber, stretched out taut and held at the edges. This sheet represents all of space and time. Now, if you place a heavy ball, say a bowling ball, in the center of the sheet, what happens? It sinks down, creating a deep, curved well in the rubber. This is what massive objects like our sun do to space-time. They curve it. They create a gravitational well. Now, if you roll a small marble near the edge of that well, it won't travel in a straight line. It will follow the curve of the rubber sheet, spiraling around the heavy ball. This is what a planet does. The Earth is not being pulled by a mysterious, invisible rope tied to the sun. The Earth is simply following the straightest possible path through a curved space. Gravity is not a force in the traditional sense. It is the geometry of the universe. It is the shape of the fabric. This fabric is not just a metaphor. It is the underlying reality. It can bend and warp. When two massive objects like black holes collide, they create ripples in the fabric, gravitational waves that travel outward across the cosmos, like the ripples from two stones dropped in a pond. The space you are in right now is constantly being jiggled by these faint, distant ripples. The fabric is alive with motion. For a long time, we thought this was the whole story of the fabric. It was a passive stage, and its shape was dictated entirely by the matter and energy placed upon it, like the bowling balls and marbles on our rubber sheet. But the discovery of dark energy, the accelerating expansion of the universe, has forced us to reconsider the nature of the fabric itself. Dark energy suggests that this fabric is not passive. It has its own life, its own will to expand. Imagine now that our rubber sheet is not made of normal rubber. Imagine it is woven from a special, active material. This material has a built-in desire to be flat and to grow larger. If there were no heavy objects on it at all, this sheet would be constantly, gently stretching itself out, becoming bigger and bigger in all directions. This inherent, expansive nature is dark energy. It is not something we place on the fabric. It is the fundamental essence of the fabric. Now, let's place our heavy bowling ball back onto this active, stretchy material. Around the ball, the fabric is pulled down, stretched taut by the immense weight. In this deep gravitational well, the fabric's own desire to expand is overwhelmed. The curvature is too steep. The local gravity is too strong. The fabric is pinned down. Its will to expand temporarily quieted by the powerful presence of mass. This is your local environment. You are living deep inside the gravitational well of the Earth, which sits inside the much larger well of the Sun. Here, the fabric of space-time is held taut by gravity's embrace. Its intrinsic, expansive nature is suppressed. This is why your room is not expanding. It is why you are not expanding. The local curvature of space-time, the local force of gravity, is completely dominant. But let us now travel in our minds, away from the Earth, away from the Sun, out of the main disk of our Milky Way galaxy. As we move farther and farther away from these great concentrations of mass, the fabric of space-time becomes flatter. The gravitational wells become shallower. The fabric is less and less pinned down. And as it becomes flatter, its own intrinsic nature can begin to express itself. Out in the great, dark voids between the galaxies, the fabric is almost perfectly flat. And here, in this vast emptiness, its inherent will to expand takes over. This is where the universe accelerates. It is not that some strange force is switched on in the voids. It is simply that the restraining influence of gravity is absent. The fabric of space-time is finally free to do what it naturally wants to do: grow. The space under your bed and the space between the galaxies are made of the same active, stretching material. The only difference is that one is pinned down by gravity, and the other is free to express its true nature. Your mind can trace the unseen shape of this active emptiness. Feel it now. Feel the fabric of space in your room, held in a gentle curve by the earth beneath you. Now, let your mind's eye travel upwards. See the fabric extending out, becoming ever flatter and more serene as you leave the Earth's gravity behind. See it ripple gently around the moon. Feel it dip into the colossal well of the Sun. Now go further, into interstellar space, where the fabric is a vast, calm, nearly flat plane. And now further still, into the immense intergalactic voids. Here, you can feel it, a gentle, powerful, persistent stretching. The fabric is alive, breathing, growing. The universe is not a collection of things sitting in an empty box. The universe is the box, and the box is a dynamic, living entity. The emptiness is not an absence. It is an active player, the most powerful player in the cosmic game. It has a shape, a tension, a will. Rest in this new perception of the world. You are not just a body lying on a bed. You are a pattern of matter existing within a dynamic, curving, stretching fabric of reality. You are intimately connected to the farthest reaches of the cosmos by this single, unbroken sheet of space-time. The substance of the emptiness in your room is the same substance that is pushing the galaxies apart. We have seen how this active fabric behaves now. We have seen its effect on the light from distant stars. But what is the oldest evidence we have for its existence? To find that, we must learn to see not just starlight, but the oldest light in the universe. We must listen for the first echo of creation itself, a faint glow that comes from the dawn of time, carrying the secrets of the baby universe and the very first moments of the fabric we now call home. Of course, we have explored the very fabric of space. Now, let us seek out the oldest artifact in existence, a gentle light that has been traveling since the dawn of time, carried with a perfect picture of the infant universe. As you rest in the quiet of this moment, let your mind drift to the idea of age. Think of the oldest thing you have ever touched. Perhaps it was a weathered stone from a riverbed, or an ancient tree in a quiet forest. Maybe a fossil, the ghost of a creature that lived millions of years ago. Our world is full of these beautiful, tangible connections to a deep past. But tonight, we are going to connect with something much, much older. we are going to feel the oldest light in the universe. This light is not in a faraway galaxy or hidden in a distant nebula. It is here. It is everywhere. It is in the room with you now, passing through the walls, passing through you. It is a faint, warm glow in every direction you turn, a perfect, uniform bath of ancient energy that fills the entire cosmos. The first light of the universe is still here. To understand where this light came from, we must travel back in our minds, past the formation of the Earth, past the birth of first stars and galaxies, to a time when the universe was very young. For the first 380,000 years of its life, the universe was an unrecognizable place. It was not the dark, transparent space we know today. It was a hot, dense, and completely opaque fog. Imagine yourself floating inside a thick, luminous cloud. The light is everywhere, a brilliant, glowing white, but you cannot see through it. You cannot see your hand in front of your face. This is because the fog is made of free-flying particles. In the early universe, it was a plasma, a seething soup of atomic nuclei, protons and helium, and a sea of hyperenergetic electrons, all unbound, moving too fast to connect. And also in this soup were the particles of light, the photons. A photon could not travel far in this primordial fog. As soon as it started its journey, it would collide with free electron, be absorbed, and sent careening off in a random new direction. It was like a ball in a cosmic pinball machine, constantly scattered, unable to travel in a straight line. The universe was opaque for the same reason a cloud is opaque. Light was trapped within it, bouncing endlessly from particle to particle. The entire universe was like the surface of a single brilliant star. But all the while, the universe was expanding. The cosmic bloom was unfurling, and as it did, it cooled. The hot, dense fog grew larger, thinner, and less energetic. For 380,000 years, it continued to cool until it reached a magic threshold, a critical temperature of about 3,000 degrees. This was the moment the universe had been waiting for. At this temperature, the electrons were finally moving slowly enough to be captured by the waiting protons and helium nuclei. It was a moment of profound connection, a great cosmic settling. One by one, the free electrons were caught in stable orbits, forming the first neutral atoms of hydrogen and helium. This event is known as recombination, a great pairing up that changed the nature of reality. And in that moment, as the electrons were swept up and bound into atoms, the fog instantly cleared. The photons, the particles of light that had been trapped in an endless game of pinball, were suddenly set free. The obstacles were gone. For the very first time, the universe became transparent. Light was free to travel in a straight line, to journey across the cosmos unimpeded. The light from that moment, from every point in the universe all at once, began to stream outwards in all directions. This is the light that is washing over you tonight. It has been traveling for 13.8 billion years to reach you. It is the oldest photograph in existence, a perfect snapshot of what the entire universe looked like at the precise moment it turned clear. We call this light the cosmic microwave background. Why microwaves? Because as this ancient light has journeyed across the cosmos, it has been stretched by the expansion of space, the cosmic redshift we have felt before. The brilliant, hot, yellowish-white light of that first moment has been stretched by a factor of over 1,000. Its waves are now incredibly long and low in energy. It is no longer visible to our eyes, but we can detect it with radio telescopes. It has been stretched all the way into the microwave portion of the spectrum. It is the afterglow of creation. Imagine a flashbulb going off in a perfectly mirrored room. The light of that initial flash would continue to bounce around the room forever, but with every passing moment, it would grow fainter, its energy fading. The cosmic microwave background is that first flash of transparency, still echoing to the universe, fainter and redder than it once was, but still present, still detectable. It comes from every direction you look. If your eyes could see in the microwave spectrum, the entire night sky would not be dark, but would glow in almost perfectly uniform, gentle light. When old analog televisions were tuned between stations, a small percentage of that snowy static was the television's antenna picking up this ancient light. You have seen and heard the echo of the Big Bang. Let this thought comfort you now. The universe is not a cold, dark, empty place. It is filled with the warmth of its own birth. As you drift in the quiet of your room, you are bathing in the oldest light. It is a gentle, cosmic blanket, the residual heat from the first morning of time. You feel its gentle warmth on your skin as you drift, a connection to the very beginning of the story. It is a soft, ancient light that holds all the secrets of beginning, and it does hold secrets. For while we say this light is almost perfectly uniform, it is that is the most important part of the story. When we look at this photograph of the baby universe with incredibly sensitive instruments, we find that it is not perfectly smooth. There are tiny, minuscule variations in its temperature, fluctuations of just 1 part in 100,000. Some spots are ever so slightly warmer, and some are ever so slightly cooler. These are not imperfections. These are the seeds of everything you have ever known. These tiny ripples in the primordial fog are the first hints of structure, the places where matter will begin to clump together under gravity's embrace to form the first stars and galaxies. They are the key to understanding the cosmic recipe, and the first evidence we have of the great tug-of-war that still shapes our universe today. We will look closer at this beautiful, ancient photograph and the secrets hidden in its ripples in our next chapter. Of course, we have bathed in the oldest light. Now, let us look closer at that ancient photograph and learn to read the faint, delicate patterns that were the blueprint for everything that exists today. Rest your awareness in the gentle, universal glow of the cosmic microwave background. This ancient light, this echo of the moment the universe first became clear, surrounds you like a comforting warmth. We picture it as a perfect, uniform light, a smooth and featureless photograph of the infant cosmos. But when we look with our most sensitive instruments, we find this is not quite true. Within that ancient light are tiny, faint ripples. Imagine looking down upon the surface of a vast and impossibly calm ocean. From high above, it appears to be a perfect, glassy sheet of blue. But as you descend, as you look closer, you begin to see that the surface is alive with texture. It is covered in a complex pattern of tiny, gentle waves and swells, a subtle tapestry of motion. The photograph of the baby universe is just like this. It is textured with tiny temperature variations, some spots being just a fraction of a degree warmer, some a fraction of a degree cooler than the average. These faint ripples are the most important features in the entire cosmos. They are the first seeds of galaxies, the first whispers of structure. The slightly warmer, denser spots are the regions where, by pure chance, there's a tiny bit more matter than elsewhere. In these regions, gravity's embrace had a slightly stronger foothold. The cooler, less dense spots were the regions that would, over billions of years, empty out and become the great silent voids. Think of a smooth, untouched field of snow on a calm day. Now imagine that a few nearly invisible grains of sand were sprinkled across it before the snow fell. As more snow falls, it is more likely to stick to those few heavy grains. Over time, small mounds will begin to form around them, growing into larger and larger snowballs. The ripples in the primordial fog were those first grains of sand. They were the starting points, the nucleation sites around which gravity would patiently build all the magnificent structures we see in the universe today. Every star, every galaxy, every great cluster of galaxies grew from one of these tiny, ancient seeds. But what created these ripples in the first place? To understand this, we must listen to the sound of the baby universe. Before the fog cleared, that hot, dense plasma was not silent or still. It was ringing like a bell. It was thrumming with colossal sound waves, or more accurately, pressure waves. It was a cosmic symphony. Imagine the universe as a vast drumhead. The Big Bang was the initial strike that set the entire drum vibrating. Two great forces were at play in this vibration. Gravity, the inward pull, was constantly trying to compress regions of plasma, to make them denser. But as it did, the intense heat and pressure of the trap light, the photons, created a powerful outward push, causing the region to bounce back. This cosmic contest of push and pull, of gravity compressing and light pressure expanding, created oscillations, waves that traveled through primordial fog. The universe was filled with these waves, of every possible size and frequency, all overlapping to create a complex, resonant hum. The ripples we see today in the cosmic microwave background are a snapshot of those waves, frozen in place at the exact moment the universe became transparent and the light was set free. It is a perfect recording of the sound of the infant cosmos. And just like the sound of a musical instrument can tell you about the instrument itself, the sound of the universe can tell us about its fundamental properties. By studying the ripples, we can learn about the universe that created them. We don't use a microphone. We measure the size of the ripples themselves. When we analyze a photograph of the ancient sky, we find that while there are ripples of all sizes, there is one characteristic size that appears more often than any other. This is the fundamental note of the cosmic symphony. This preferred size acts as a perfect standard ruler for cosmology. We know how large these sound waves actually were at the moment the light was released. By measuring how large they appear to us in the sky today, we can determine the geometry of the universe and its history of expansion with incredible precision. It's like seeing a friend you know is exactly 6 feet tall standing on a distant hill. By how small they appear, you can accurately judge the distance to that hill. The ripples are our 6-foot-tall friend in the baby universe. So what do these ripples tell us? They tell us a story that is breathtaking in its coherence. When we build a model of the universe using the strange cosmic recipe we discovered, with 5% ordinary matter, 25% dark matter, and 70% dark energy, that model makes a very specific prediction about what the ripples should look like. It predicts the strength of the fundamental note and all of its cosmic overtones. And when we compare that prediction to the actual data, the real photograph taken by our satellites, the two match with almost unbelievable perfection. It is one of the most stunning successes in the history of science. The ancient ripples confirm our strange recipe. They tell us that the universe is geometrically flat on large scales, and they confirm that the gentle, accelerating push of dark energy has been a component of the universe from the very beginning. Its presence affected how those sound waves traveled, and its signature is written into that ancient light. Rest now in the beauty of this thought. The universe is not just elegant. It is coherent. The story told by the lighthouses of dying stars in the distant universe is the same story told by the faint, ancient ripples in the afterglow of creation. Both point to the same strange and wonderful reality, one dominated by the gentle, persistent push of an unseen energy. We have now looked back to the very edge of time. We have seen the seeds. So, where do we look to see the great forest that has grown from them? We turn our gaze back to the modern universe, to see how those tiny fluctuations have blossomed over billions of years into the largest and most beautiful structures imaginable. Of course, having examined the blueprint of the infant universe, let us now travel forward in time to witness the magnificent structure that has grown from those ancient seeds, and to listen to the grand music of its creation. Settle into the quiet of this moment, your body at rest, your mind calm and open. In our last chapter, we journeyed back to the dawn of time and saw the faint ripples in the primordial fog, the tiny seeds from which all future reality would grow. Now, let us return to the present. Let us travel forward through billions of years of cosmic evolution and see what has become of those seeds. Let us look upon the universe as it is today. If you could zoom out from your room, from your planet, from your galaxy, and see the entire cosmos on its grandest scale, what would it look like? You might imagine a random scattering of light, like salt spilled across a vast, dark table, a uniform and chaotic distribution of galaxies, spread out evenly in all directions. But the universe is far more artful than that. It is more ordered, more beautiful. The universe is not random. It is a web of galaxies. To understand how this beautiful structure came to be, we must first honor the great cosmic weaver, gravity. Remember those tiny, slightly denser spots in the ancient fog? They were the starting points. Gravity, with its patient and relentless embrace, began to work on them. At first, its pull was infinitesimally weak, but it never tired. Over millions of years, it began to pull more matter toward these regions. First came the invisible dark matter, the mysterious substance that feels gravity's pull but does not interact with light. It formed vast invisible clouds or halos around the initial seeds. These halos were the invisible scaffolding of the cosmos. Then, the ordinary matter, the luminous gas we can see, was pulled into these dark matter halos, like rivers flowing into unseen valleys. As the gas fell into these gravitational wells, it cooled, condensed, and ignited into the first generations of stars. These stars then gathered into the first infant galaxies. Imagine watching this process over eons. It is like the flow of water across a landscape. The tiny, dense seeds are like the highest points of a watershed. Gravity guides the flow of matter, pulling it into small rivulets. These rivulets merge into larger streams, and the streams flow together to form great, shimmering rivers. The galaxies are the light sparkling on the surface of this cosmic water, and their motion reveals the unseen shape of the gravitational landscape beneath. This process, over 13 billion years, has resulted in the most magnificent structure in nature, the cosmic web. As you drift in your mind's eye, you can see it now. It is a luminous three-dimensional network of breathtaking scale and complexity. You see the long, brilliant filaments. These are the great rivers of the cosmos, strands of galaxies and gas stretching for hundreds of millions of light years, connecting the entire universe in a glowing network. Our own Milky Way is a resident of one such filament. Where these filaments intersect, you see the great clusters. These are the cosmic cities, the bustling metropolitan hubs of the universe. Here, thousands of galaxies are packed together in a dense, brilliant swarm, all orbiting a common center of gravity. They are the largest gravitationally bound objects in the universe, great lakes of light and matter into which the filaments flow. And between this luminous lacework, you see the vast, dark voids. These are the quiet, empty spaces that grew from the cooler, less dense ripples in the primordial fog. They are immense, nearly spherical regions containing very few galaxies. They are the peaceful, dark countryside of the cosmos. Their silence is as profound and as important as the brilliance of clusters. This entire structure, filaments, clusters, and voids, resembles a neuron or the delicate structure of a sea sponge or a web of shimmering lace thrown across the darkness. It is beautiful, organic, and profoundly orderly. This is the great work of gravity, the weaver. But gravity is not the only artist shaping this masterpiece. While gravity weaves the strands of the web, dark energy is stretching the loom. As gravity works to pull matter together along the filaments and into the clusters, dark energy, the inherent, expansive energy of space itself, is working everywhere at once to push the entire structure apart. Think of our cosmic web as an intricate pattern of cinnamon swirled inside a loaf of raisin bread. Gravity is the force that holds the cinnamon in its beautiful, swirling pattern. Dark energy is a yeast in the dough, causing the entire loaf to rise and expand. As the bread rises, the swirls of cinnamon are stretched further and further apart from each other. So it is in the cosmos. The filaments are being stretched longer. The great voids are growing larger and more empty. The grand clusters, the cosmic cities, are moving away from each other at an ever-increasing speed. This is the great cosmic symphony of push and pull. It is not a violent battle, but a beautiful and complex musical composition. Gravity is the deep, rhythmic percussion, the powerful bass line that pulls everything into dense, resonant chords in the galaxy clusters. It is a force of structure and intimacy. Dark energy is a swelling, ethereal sound of the strings in the choir, a high, sustained note that lifts the entire composition, making it more spacious, more minimalist, more grand. The universe you are in tonight is a result of these two competing, yet complementary musical themes. And where are you in this grand concert hall? Our galaxy, the Milky Way, is not in one of the brilliant, crowded cities of a great cluster, nor are we lost in profound silence of a great void. We are in a quieter place, a suburban filament of the cosmic web. You are listening from a quiet seat, with a perfect view of the grand performance. From here, we can see the brilliance of the distant cities and feel the peaceful pull of the nearby streams, all while resting in a place of relative calm. You can feel this symphony in your own state of rest. The gravity that holds you to your bed is the deep, percussive rhythm. The gentle, quiet expansion of space that fills your room's ethereal, swelling note of the cosmic choir. You are at the very heart of the music, a conscious listener in the most beautiful symphony of all. As you rest here, surrounded by the gentle quiet of night, turn your awareness to the rhythm of your own breathing. Feel the slow, steady rise of your chest as you inhale and the soft, complete release as you exhale. There is a constancy to this rhythm, a reliability that brings comfort and peace. It is the steady, quiet engine of your rest. We have journeyed far in our understanding of the cosmos. We have felt gravity's familiar embrace and the surprising, accelerating push of dark energy. We have seen how these two forces weave the beautiful, luminous web of the universe. We understand their roles in the grand cosmic symphony. But now, as we settle into a deeper state of calm, a new, more subtle question arises. A question about the very nature of that mysterious, accelerating push. Is this dark energy a constant, unchanging thing? The question hangs in the air, as soft and persistent as the slow rising and falling of your chest. Is the push that is accelerating the universe a fundamental, steady feature of reality? Or is it something else, something that could change, something that might be different tomorrow than it is today? Let us first consider the simplest, most elegant possibility. This is the idea that dark energy is what we call a cosmological constant, a true, unwavering constant of nature, as fundamental as the speed of light or the strength of gravity itself. In this view, dark energy is an intrinsic property of the fabric of space-time. The amount of energy contained in each cubic centimeter of the vacuum is a fixed and unchanging value. It was the same a billion years ago. It is the same now, and it will be the same a billion years from now. Imagine the deep blue of the ocean. It is a fundamental property of the way water interacts with light. The ocean's color is a constant. Dark energy, in this view, is like the color of space-time. It is simply its nature. Or think of a perfectly silent room that is nonetheless filled with a faint, steady hum. A single, pure tone that never changes in pitch or volume. This is the cosmological constant, a fundamental frequency of reality itself. If this is true, the future of the universe is set. The acceleration is steady and predictable. The cosmic bloom will continue to unfurl at a stately, ever-increasing pace that follows a simple, beautiful mathematical rule. It is a clean, elegant, and deeply satisfying idea. It is a solution that Einstein first wrote down, the idea that the very fabric of reality has a built-in resilience, a gentle, constant springiness. But there's another possibility, one that is more complex, and perhaps more mysterious. What if dark energy is not a constant? What if it is a dynamic entity, something that changes over cosmic time? Some scientists have given this idea a beautiful name, quintessence. The name harks back to the ancient Greeks, who believed in a fifth element, a perfect, celestial substance that filled the heavens. In this view, dark energy is a new kind of energy field, a phantom field that permeates all of space, like an invisible, ethereal fluid. And like any fluid, its properties can change. If the cosmological constant is like the unchanging blue color of the ocean, quintessence is like the ocean's temperature. It might be warm now, but it could have been cooler in the past. It could be growing warmer, or it could be fluctuating in unpredictable ways. If dark energy is this phantom field of quintessence, then the steady hum we hear in the universe might not be so steady after all. Its pitch could be changing. It might be growing higher, meaning the acceleration will become even more pronounced. Or the pitch could be dropping lower, meaning the acceleration might one day slow down, stop, or even reverse, allowing gravity's embrace to become dominant once more. This possibility makes the future of the universe an open question. It suggests a more complex, perhaps more organic, character for dark energy. Not a static property of space, but a dynamic player in the cosmic drama, one whose own story is still unfolding. So how do we find the answer? How do we know if we are living in a universe with a simple, constant push or a complex, changing one? The answer lies in making even more precise measurements of the cosmos. By studying distant supernovae and the intricate patterns of the cosmic web with extraordinary accuracy, astronomers are trying to listen to the history of the cosmic hum. They are charting the expansion rate at different points in the past to see if it has been perfectly consistent, or if it has varied. So far, the evidence we have gathered is consistent with the simpler idea, the cosmological constant. The hum appears to be steady, but our measurements are not yet sensitive enough to rule out a slow, subtle change. The question remains one of the most important and tantalizing in all of science. And as you rest here, drifting in a quiet space between wakefulness and sleep, There's a deep peace to be found in this uncertainty. The universe is not a book that has already been written, a puzzle that has been solved. It is a living, breathing story, and we are just beginning to learn its language. To be able to ask such a profound question, to even know that there's a question to be asked, is a gift. The mystery is not a source of anxiety, but a wellspring of wonder. The gentle rise and fall of your chest continues, a steady, constant rhythm in your own personal universe. Does the grand universe beyond your walls share the same constancy? We do not know. But while these grand cosmic questions hang in the balance, a more intimate question might arise in your mind. If the whole universe is expanding, if space itself is stretching, why does the space in your room feel so stable? Why aren't we being stretched apart? The answer lies in returning our focus from the grandest scales to the smallest, and finding our safe and steady home within the great expansion. Of course, we have contemplated the great cosmic questions. Now, let us return our focus to our own quiet place in the universe and find comfort in our sanctuary of stillness. Breathe in the quiet air of your room. Feel the steady presence of the world around you, the solidness of the bed, the stillness of the walls, the silent companionship of the objects nearby. Everything feels firm, reliable, and still. And yet, we have learned a profound and startling truth. The universe, on its grandest scale, is anything but still. The very fabric of space is alive with a gentle, accelerating push, carrying the great island galaxies away from each other into an ever-widening ocean of night. This truth can feel unsettling at first. If the very space we inhabit is stretching, a question naturally arises in quiet of the mind. Why aren't we stretching with it? If the universe is expanding, why is your room not expanding? Why is your body not being pulled apart? The answer is a beautiful lesson in scale, and it is the source of a deep and profound comfort. You are a sanctuary of stillness in a cosmos of motion. Think of dark energies pushed not as a violent force, but as the gentlest, most subtle whisper imaginable. It is a pervasive pressure that is equal everywhere, but it is also incredibly weak. Its power only becomes apparent over vast, empty distances, where there is little else to stand in its way. It is the quietest voice in the cosmic choir, a voice that can only be heard when all the other, louder singers are far away. Here, in your room, in your body, there are other voices, other forces, that are singing with a power that is almost infinitely louder. Let us start with the forces that hold you together. Consider the book on your nightstand or the fabric of your blanket. What makes them solid? What stops your hand from passing right through them? The answer is the electromagnetic force. This is the force that binds atoms into molecules and molecules into the complex structures of the world you know. It is the intricate, powerful weave that holds the threads of reality together on a microscopic scale. Imagine two powerful magnets snapped together. The force holding them is immense. Trying to pull them apart takes real effort. The bonds between the atoms in your body are like this, but a billion times stronger and more numerous. Compared to this powerful, intimate, and intricate molecular embrace, the gentle, expansive push of dark energy is nothing. It is like a single, gentle breath trying to push over a mountain. The mountain does not notice. The bond that hold you together are stronger. Your body is not expanding. Now let's zoom out. What about the earth itself and our place upon it? Here, another force reigns supreme, gravity. Feel its familiar, comforting weight holding you to your bed. The Earth's gravitational embrace is a colossal force. It holds the oceans in their basins. It holds the atmosphere around us like a shimmering cloak. And it holds you, your home, and everything you have ever known securely to its surface. The gentle push of dark energy is still here, trying to expand the space between you and the center of the Earth. But its effort is utterly insignificant compared to the immense gravitational pull you feel right now. You're living deep inside a gravity well, a steep valley in the fabric of space-time. Dark energies pushes like a tiny, gentle breeze trying to blow you up the side of a steep mountain. It has no effect. The gravity of the Earth is overwhelmingly dominant. Your room is not expanding. Let's zoom out even further, to the scale of our solar system. The sun's gravitational embrace holds all the planets, including our Earth, in a graceful, predictable dance. The sun's gravity is so powerful that it dictates the shape of our entire cosmic neighborhood. Dark energy is still there, trying to push the Earth and Jupiter apart. But again, its influence is completely trivial. The planets are not drifting away from the sun into the void. The bonds of our solar system are secure. And finally, let us zoom out to the scale of our galaxy, the Milky Way. Our galaxy is a vast, self-contained city of over 200 billion stars, all held together by their mutual gravitational pull, and an even greater pull of the invisible dark matter that surrounds them. It is a magnificent, swirling island of matter, a gravitationally bound sanctuary. The stars in our galaxy are not expanding away from each other. The Milky Way is not growing larger. It is a stable, cohesive structure, sailing through the cosmos as a single entity. So, you see, you are protected from the great expansion by a series of nested sanctuaries. Your body is a sanctuary, held together by the powerful bonds of electromagnetism. Your planet is a sanctuary, held together by gravity. Your solar system and your galaxy are sanctuaries, great islands of gravitational order. Imagine you are on a large, sturdy ship sailing across a vast ocean. A powerful current is flowing in the ocean, causing all the ships to drift apart from one another. But you, on the deck of your ship, do not feel this current. The ship itself is not stretching or being pulled apart. It is a solid, stable home. You can walk from one end to the other, and the distance is always the same. You are safe on your island, even as the sea between the islands grows wider. This is your place in the cosmos. You are a passenger on Starship Milky Way. Feel the safety and peace of your own small, stable place in this grand, unfolding story. The universe can expand, it can accelerate. It can be filled with mysteries we are only just beginning to grasp. But here, in your sanctuary, you are still. You are whole. You are home. Of course. We have found our safe harbor in the expanding cosmos. Now, let us cast our minds far into the future, not with fear, but with a calm and peaceful curiosity, to see where this great cosmic current is taking us. As you rest in your sanctuary of stillness, held by the familiar embrace of gravity, let your sense of time begin to soften and expand. The moments stretch into minutes, the minutes into a long, peaceful hour. Now, let your mind drift even further, beyond the horizon of tomorrow, past the coming seasons, beyond the span of your own life. We are going on a journey to the deep, deep future, to a time so distant it is almost beyond imagining. We are going to see what becomes of our blooming, accelerating universe. If the gentle, persistent push of dark energy continues, it is indeed a constant property of space, then the future will be one of profound and growing solitude. To understand this future, imagine yourself standing on a shore at twilight, watching a fleet of ships sail out to sea. At first, you can see all of them clearly, their lights like a small constellation on the water. But the ships are all moving away from you and from each other. The ones that are farthest away seem to be moving the fastest. Eventually, the most distant ships will reach the horizon, that soft, curved line where the sea meets the sky. They will seem to sink below it, their lights winking out one by one, until they are gone from your sight forever. Our accelerating universe has a horizon like this. It is not a physical edge, but a horizon of information, a point of no return for light. As distant galaxies are pushed away from us by dark energy faster and faster, they will eventually reach a point where they are receding from us faster than the speed of light. This does not violate any physical laws, because it is a fabric of space itself that is stretching, but the consequence is profound. The light that leaves that galaxy, fighting to travel back towards us, is like a runner on a treadmill that is moving too fast. It can run forever, but it will never reach us. It can never cross the growing expanse of space between us. The galaxy will, from our perspective, cross over the cosmic horizon. We will see its light become more and more redshifted, its song stretch into an impossibly low note, until it fades completely from our view. It will vanish from our sky as surely as a ship sinking below the sea. This is the fate of our night sky in the far future. Let your mind drift forward through the eons. For now, our sky is rich and brilliant. With our powerful telescopes, we can see billions of other galaxies, a testament to a young, connected universe. But as the billions of years pass, the great cosmic expansion continues to accelerate. One by one, the most distant galaxies will cross the cosmic horizon and disappear. The great clusters and superclusters will wink out of existence from our point of view. The cosmic web, that beautiful, luminous structure, will be stretched so thin that its strands will snap and its light will no longer be able to cross the voids. The sky will slowly, peacefully empty. There will be one last, spectacular dance before the great quiet descends. Our own Milky Way is part of a small collection of gravitationally bound galaxies called the Local Group. Our nearest large neighbor, the Andromeda Galaxy, is actually moving towards us, its gravitational embrace strong enough to overcome the cosmic expansion between us. In about 4 billion years, our two galaxies will collide and merge, a slow, graceful intermingling of trillions of stars, creating a new, even larger island galaxy, which some have called Milkomeda. For a time, the sky for any inhabitants of this new galaxy will be a place of breathtaking beauty and turmoil. But after this final local gathering, the great fading will resume. Our new supergalaxy, this final sanctuary of matter, will be a single island of light in an ever-expanding, ever-emptying sea. All other galaxies will have crossed the horizon. Their light will be lost to us forever. Imagine standing on a world in this impossibly distant future. You look up at the night sky. You see the brilliant, dense river of stars of your own galaxy, a magnificent spectacle. But beyond it there is nothing, only a profound, absolute, and unending blackness. The sky will be devoid of any other galaxies. It will offer no clue that there was ever anything else. Future astronomers on this world would have no way of knowing the story we know now. They would not see the redshift of distant galaxies, because there would be no distant galaxies to see. They would have no evidence of the Big Bang, no hint of an expanding universe. They would look at their single, isolated island of stars and likely conclude that this was all there ever was, that the universe was static, eternal, and solitary. The story of our cosmic origins will have been erased by the expansion itself. This is not a sad thought, but a peaceful one. It is the universe returning to a state of simplicity, a slow fading into a deep and final sleep. And the fading does not stop there. Within our own isolated island of stars, the lights will also, one by one, begin to go out. The great cycle of star birth will cease. As the free gas is used up, the existing stars will burn through their fuel and die. The brilliant blue and white stars will be the first to go, followed by the yellow suns like our own. The last lights to remain will be the small, dim, red dwarf stars, which sip their fuel so slowly they can last for trillions of years. But eventually, they too will fade, leaving behind only the stellar ghosts. The cold, dark embers of white dwarfs, the silent, spinning neutron stars, and the profound blackness of black holes. The universe will become a place of immense quiet and cold, a kingdom of darkness populated only by these fading remnants, all drifting ever further apart in the silent, accelerating expansion. It is the ultimate state of rest, a final, peaceful entropy. As you drift now toward your own state of rest, feel the connection to this distant future. Your own consciousness is slowly fading, the bright thoughts of the day giving way to the quiet darkness of sleep. It is a letting go, a peaceful release. The universe, in its own grand way, is doing the same thing. It is letting go of its structure, its heat, its light, and returning to a state of profound, simple peace. To be here now, in this warm, bright, youthful era of the universe, to be able to look up and see the sky full of neighbors, to know the story of our beginning, is a rare and precious gift. Cherish it as you drift into the quiet darkness of your own peaceful sleep. Of course, we have explored the most likely path for our universe, a long and peaceful fade into quiet solitude. Now, let us entertain one last, fleeting thought about the future, a different kind of dream, before we let our minds settle into their final rest. Settle into the deep peace of this moment. Let the story of the long, slow future of the cosmos be a comfort to you. It is a story of a gentle fading, a universe slowly exhaling, a final and profound stillness settling over all things. This is a future our best understanding points towards, a future of quiet and rest. It is a story that resonates with the journey you are on right now, a slow and peaceful drift into quiet asleep. But in the world of thought, an imaginative playground to science, there are other stories, other possible futures. They are not predictions, but speculations, not probabilities, but possibilities. Let us, just for a moment, consider one such possibility. Let us entertain a phantom thought, a different dream of the future, not to be held on to, but to be witnessed and then gently released, like a strange cloud passing across the face of the moon. What if the push grows stronger? Remember the question we asked earlier in our journey? Is dark energy a constant, unchanging property of space, or is it something dynamic, a phantom field that can change over time? We called this idea quintessence. Our most likely model suggests that if it changes at all, it does so very slowly or not at all. But what if we imagine a more dramatic form of this field? A hypothetical form of energy whose repulsive force does not stay constant, but actually grows stronger with time. Imagine the gentle, expansive push of dark energy not as a steady, constant breeze, but as a wind that is slowly, imperceptibly picking up speed. For billions of years, it is just a whisper, but it is a whisper that is destined to become a gale, and then a hurricane, and then a storm so powerful it could overwhelm all other forces in nature. This is the idea of phantom energy. If this phantom energy exists, then the future of the universe would be very different from the slow, gentle fade we have just imagined. The acceleration would not just be steady. It would become runaway. The expansion would feed on itself, growing more and more violent with every passing moment. This is a different dream of the future, a scenario known as the Big Rip. Let your mind watch this dream from a safe, comfortable distance, as if watching a strange and silent film. Do not feel it, just observe it. In this future, the unraveling happens in stages, from the largest structures to the smallest. In the final billions of years before the end, the ever-strengthening push of phantom energy will become powerful enough to overcome the gravity that holds the great clusters of galaxies together. These cosmic cities would dissolve, their member galaxies flying apart into the growing darkness. Then, as time accelerates toward the end, the push will become stronger still. Just a few million years before the final moment, it would overwhelm the gravity that holds individual galaxies together. Our great island of Milkomeda, the result of the merger of our galaxy and Andromeda, would be torn apart. Its trillions of stars would be flung into the void, their gravitational bonds broken forever. The clock ticks faster. In the final months before the end, the push will become strong enough to overcome the gravitational pull of individual stars. In our own solar system, the Earth would be ripped away from the sun, sent careening into the dark. The planets would all be unbound, their ancient, stately dance ending in a final, silent scattering. In the last minutes, the push would become so immense that it would overwhelm the forces holding the stars and planets themselves together. The Earth would be pulled apart. The sun would be torn asunder. All solid objects would disintegrate into their constituent atoms. And then, in the final, fleeting fraction of a second, the phantom energy would become so powerful that it would overcome the last and strongest bonds in nature. The electromagnetic force that holds atoms together would fail. The atomic nuclei themselves would be broken apart. The very fabric of space-time would be torn into an infinite number of disconnected pieces. And then not a fire or ice, but a universal, instantaneous unraveling. Now, let that thought go. Release it. Watch it dissolve like a wisp of smoke in the calm night air. It is only a whisper of a possibility, a fleeting thought that dissolves as you sink deeper into comfort and stillness. This story, The Big Rip, is the most extreme speculation. It is based on a hypothetical form of energy for which we have absolutely no evidence. All of our best observations suggest that the universe is not heading this way. The cosmic hum appears steady. The breeze is not picking up speed. We entertain this phantom thought, not to cause distress, but to better appreciate the reality you are in right now. The reality you can feel is one of immense stability. Feel the bonds that hold the atoms of your body together. They are strong. Feel the gravity that holds you to your bed. It is constant and secure. Feel the peace of your sanctuary, your home in expansion. It is safe. The Big Rip is a ghost story that scientists tell each other around a campfire. It explores the very limits of physical law. But it is not your story. Your story tonight is one of peace. It is one of letting go, not into a violent unraveling, but into a gentle, restorative sleep. The thoughts of the day, like distant galaxies, can drift away. The worries and concerns, like fleeting phantom thoughts, can dissolve into nothing. You are here, now, in a universe whose true future is a deep and beautiful mystery. And in this moment, you are safe, you are still, and you are at peace. Of course, our long journey through the cosmos is coming to a close. Let us end where we began, in a state of quiet wonder, and find a deep and lasting peace not in the answers, but in the beauty of the question itself. Our journey together is coming to its end. Let your mind drift back to where we began, in the quiet of your room, looking up at a dark, peaceful, and seemingly still night sky. We began with a single breath, a simple observation, and from that point of stillness, we have traveled across billions of light years and billions of years. We have journeyed to the very edge of time and to the far horizon of the distant future. And now we return. We are back in the comfort of our own small, quiet space. But the sky we see in our minds, I will never be the same. The stillness we once saw is now alive with a grand and beautiful motion. We end where we began, with mystery. Listen now, as the story of our journey whispers back to you, not as facts to be remembered, but as the verses of a lullaby, a gentle rhythm to carry you into sleep. You heard the first whisper of expansion, the soft, red-shifted sigh of galaxies whispering goodbye. You learned to see the universe not as a static painting, but as a graceful, blooming flower, its petals unfurling in a slow, cosmic dawn. You traveled to the lighthouses in the deep, the brilliant, dying stars that flash with a perfect, known brightness, allowing us to measure the vastness of the cosmic sea. And you listened to the echoes of their ancient light, stretched by their long journey, a journey that revealed a deep and unexpected secret. You felt the impossible hurry, the stunning realization that the universe is not slowing down, but speeding up, as if a gentle river had become a silent, deep-sea accelerator. And we gave this mystery a name, a placeholder for our awe, dark energy. We learned to see it not as a monster, but as a shadow between the stars, the silence that gives the cosmic song its beautiful, spacious form. We stood before a great cosmic scale and weighed the substance of reality, only to find the astonishing truth that the weight of nothing is more than the weight of everything else combined. You rested inside that strange and wonderful cosmic cake, feeling the lightness of its mysterious, airy texture. You felt the great cosmic tug-of-war, the patient, weaving embrace of gravity and the gentle, expansive push of dark energy, a symphony of competing forces that creates the beautiful web of galaxies. You saw the seeds of that web in the ripples of the primordial fog, the very first photograph of the baby universe. And you understood that the story of the cosmos is written in its oldest light. You found your own safe harbor within this grand story, your sanctuary of stillness in a cosmos of motion, held fast by forces that are stronger than the universal push. And from that safe place, you dreamed of the futures that might be, the long, slow fade into a peaceful solitude, and the fleeting, phantom thought of a more dramatic end. Through it all, a single question has woven itself like a thread of light. What is this dark energy? And here, at the end of our journey, we find the most beautiful truth of all. Dark energy is a question the universe is asking itself. Think of it this way. The universe, for billions of years, was a place of unconscious, unfolding laws. It bloomed, it formed stars, it created galaxies, all according to profound and elegant script. But then, on a small, rocky planet, in a quiet suburban filament of the cosmic web, the universe did something new. It grew a part of itself that could look back upon the whole. It grew a part that could wonder. That part is you. Your curiosity, your ability to ask these questions, is not something separate from the universe. It is one of the ways the universe is coming to know itself. Your mind, as it contemplates the mystery of dark energy, is the cosmos contemplating its own nature. You get to be here, a part of the cosmos that can wonder about it. You are the consciousness of the stardust, the voice of the silence. And from this perspective, the answer to the question is not the most important thing. The answer may come tomorrow or in 1,000 years, or may always remain just beyond our grasp. But that does not matter tonight. What matters is the feeling you are left with, The answer is not as important as the feeling of awe it inspires. Awe is the feeling of being connected to something larger than yourself. It is a quiet reverence that falls upon you when you stand before a vast ocean or a towering mountain or a sky full of stars. It is a feeling of peace, of perspective, of letting go of the small worries of the day and dissolving into a grander reality. This is the gift of the great cosmic questions. They do not demand an answer from you as you lie here, ready for sleep. They ask only that you feel their weight, their beauty, their scale. They invite you to be humble, to be curious, and to be at peace with not knowing. Let the need for answers dissolve. Let the story of our journey become a soft, warm, and comforting presence. The universe is vast and mysterious, and you are a part of it. The same atoms that burn in distant stars are the atoms that make up your body. The same laws of physics that guide the dance of galaxies are the laws that guide the gentle rhythm of your heart. And the same great mystery that defines the edge of our knowledge is the mystery that invites you now into deep, quiet, and restorative unknown of sleep. This is a final, peaceful thought to carry you into your rest. The beauty is not in the destination. It is in the journey. The peace is not in the answer. It is in the question. And the rest is not at the end of the story. The rest is here. Now,